Hello. Good morning. Once again, welcome to all of you to this scientific gathering to celebrate 10 years of achievements of AstroSat. After the inaugural session, it is time to start the scientific deliberations. Before going for the scientific deliberations, it is important uh, to recall the people who were behind to realize these payloads, the spacecraft, and the experts, guidance force behind that to make this AstroSat mission as a unique mission. For last 10 years, it is operating fantastically in space. So Dr. Srikumar is going to moderate this session. I request Dr. Srikumar to take the dais to moderate this session. Before going to start the session, I will introduce Dr. Srikumar. Dr. Srikumar played a key scientific leadership role in coordinating payload science planning during the tenure, heading the space astronomy group at ISAC. Now it is URSC. He further improved community engagement during the tenure at the Space Science Program Office. Currently, he is the director of MAHE at Manipal. His work actually bridged astrophysicist research with mission execution, planning, utilization of AstroSat data, and we have a fruitful results. I hand over to Dr. Srikumar.
Good morning. Thank you, Anuj. This is an important session, and we begin with certain elements of historical elements that are very important for a mission of AstroSat. So as we already heard in the early 2000s when ISRO decided to take this forward, this was after 5 years of deliberations that Professor Agarwal, Professor Srinivasan and others had discussed with the scientific community, and the step towards realizing was actually taken by our former director of ISAC, ISRO Satellite Centre, Dr. P.S. Goel. He called together the first study committee set up with Dr. Y.K. Jain as the chair, Dr. Koteshwar Rao, C.A. Prabhakar and myself, and that set put the ball rolling. And Dr. P.S. Goel in that frame, the early phase of it, where there were multitudes of discussions on configurations, experiments, many configurations thought about. There were very important meetings at TAFR. I remember an extensive discussion where Dr. Goel really suggested very important points. In particular, I think his concept of actually trying to minimize the RCS component on the spacecraft allowed us to really have a lot more capacity for science. And science today, and that's very beneficial for me. So let me invite Dr. P.S. Goel to share his thoughts during that early phase of AstroSat.
Good morning to you all. Dr. Srikumar and Professor Agarwal, they came to my room one day and talked about this satellite, multi-wave observations from the space. Now my immediate question was whether anyone else has launched this satellite, this type of satellite. And of course they searched everywhere and they came out that no, this will be the first satellite of this kind. So that's what attracted me that we should take up this. I had earlier interacted with Professor Agarwal in IRSP3. In fact, that was a milestone satellite for, you can say, taking up the AstroSat. We have not talked much about P3, but that was an important satellite because from the engineering point of view, there was this first satellite we built where we can look anywhere on any star and look at it for weeks and months. And that capability actually encouraged us to take up this satellite, AstroSat. The immediate task was having a project director. Now, you know, a project director who appreciates engineering as well as science. So somehow I just thought the name of Koteshwar Rao and talked to Dr. Alex. Obviously, he was because he was director of Helios, he was reluctant because he's the best. I was asking his best man. And similarly, Koteshwar also was a bit reluctant. But then, you know, there is a culture of ISRO. Because once you are asked to do something in the context of either nation or ISRO, then the personal choices don't matter. So obviously, he was happy to release, and Koteshwar Rao came to ISAC from Laos. You know, there was a lecture by Professor Sarabhai. I have not interacted much with him. Only once he came to, when I was SSD. But in that lecture, which was just evening of the day or night, he died. There was a lecture in the hall of VSSC, not hall, it's an open space. And he made a statement that if you have to get a task, actually he was making a statement for our elders. I was just 1.5 years into the ISRO that time. He said that you find a person, right person, and leave it to him. Don't interfere too much. He will deliver. Have confidence. So I just, that sentence which he made, it was there in my mind. So just you, but what do you mean by right person? That's important. For any person, there are two things. One is a competency, other is a commitment. If any one of is missing, he is not right person. So to me, there was a reason for going to this exercise. Of course, as we do normally all the routine things in the project, we did that. I don't think we have to narrate that part. But that was the important foundation of this project, IRSP3, and then having a team which is so committed and so competent. Of course, later I was asked to do something else. Not that I left ISRO or ISAC, but I was given another task of making the Ministry of Earth Science. But even then, I was keeping in touch. This particular conference or meeting gives me confidence that we have achieved so much because of the AstroSat. Why? Organizers had to run 3 parallel sessions. That still shows that the outcome of this project. Now, I just want to give one more task to our organizers, particularly Dr. Shiv Kumar. You will be making a lot of abstract, lot of summaries, lot of things. I need 1 page, maximum 2, on outcome of the AstroSat in last 10 years, which is really telling that we have made this breakthrough in the science, which is only because of AstroSat. I think that's the one thing I thought I would like to give a task. And with that, thank you very much for calling and making part of your journey. Thank you.
Thank you, Dr. Goel. I also want to add the fact that this kind of support Dr. Goel provided to the Technical Physics Division, which used to be called Technical Physics Division, which we later morphed into Space Astronomy Group. And the confidence he had in us was actually very critical in allowing us to interact very closely with the academic institutions in the country. And so today that tradition continues, and thank you very much for that issue. Now, following Dr. Goel's term at URSC, Dr. T.K. Alex had already deeply involved in AstroSat from Leo's perspective. He took the bold decision to really promise a primary mirror for the UV telescope. Not something that is not a simple task and quite a tall order, but he did really take that up in a very serious manner. And in that early phase of it, while he was still busy with Chandrayaan-1 related aspects, he was also deeply supporting AstroSat issues. And finally, the team that he worked with, Dr. T.G.K. Murthy, Dr. C.L. Nagendra, and others at LEOS, we managed to put together an incredible UV telescope. May I now request Dr. T.K. Alex to really say a few words in this regard?
Good morning. I'm very glad to be amongst the AstroSat family of scientists and administrators. AstroSat is one of the best executed satellite projects of ISRO, I would say. ISRO scientists had experience in different astronomy missions right from the very first satellite, Aryabhat, for which myself, Dr. Goel, were also part of those great missions. That satellite also had a contribution from different organizations. Besides ISRO, we had a scientific payload from TIFR, PRL, and we had very good experience with that satellite, the very first satellite. It had an X-ray payload. It worked only for a few days, but it produced signals, very good signals from X-ray sources. Unfortunately, the satellite was tumbling. Nobody knew The signal was very good. I could had a look at the signal along with Dr. Kasuri Rangan, Professor U.R. Rao. The signal was very good, but they don't know from where it is coming, because the sensors in a tumbling mode were working in a slightly erratic way. So we had a magnetometer, triaxial magnetometer, which I designed, and it was a part of the mission. So with a lot of difficulty, I tried to interpret from that tumbling mode where this satellite is looking. After about a month of extensive trial and error, etc., I could find it is from a real X-ray source, from the cataloged things, the Uhuru sources we could identify, and most importantly, a result could be published in Nature after identifying the source. It was a very gratifying effect. That's how I came to the astronomy activities and pointing accuracies and how to look at the different places in the sky. That was my specialty. So a laboratory for electro-optics was established in Bangalore, specifically making star sensors, earth sensor, etc. The star sensors become a very important part of such missions. We had experience of star sensors with a 10 arc-second accuracy. So when we talked about this AstroSat, it is a collective idea of many scientists together to have a multi-wavelength satellite in orbit. But a tall order was there. The satellite should be pointing, at least the star's position should be known within 1 arc-second. We had experience only about a 10 arc-second star sensors. So that was not good enough. We can point somewhere very close to the object, but not to the exact position. So, but we had very good gyroscopes. It has got stability. Okay, much better than the star sensor. Star sensor can point very close, 10 arc-seconds, but we need to go to 1 arc-second. So the control system, people are asked about it. They had good experience in IRS P3. Dr. Goyal was telling you about the IRS P3. We could point to stars, the stellar objects for weeks together. So that was the experience we had. Later, we found there is some other way of doing the system to better than the 10 arc-seconds. So where the Professor Tandon and team came into picture, post-launch, how to restore the images. So the stellar images were restored by integrating multiple flashes or multiple images together, and finally the data could be integrated, and we could produce one of the best images of sharpness. So I would say the credit goes to not only the optics, but also the post-launch integration of images, putting together and making very sharp images. Thank you very much, Tandon and team, for doing this wonderful work. The LEOS had the task of making the UV telescope. We never did any UV telescope at that time. We have been doing only infrared telescope. Optics were made one visible telescope. The task came, can you do this UV telescope? We said we can do it. When we started only found that it is not so easy because the wavelength is shorter than the visible wavelength. So surface accuracy has to be very good. You cannot have scratches. It will give a lot of problems with the image. But the technicians in LEOS and the engineers said we can do it. We had put all efforts and we could develop the ultraviolet telescope and deliver it. The problem was how to test it. Ultraviolet mirrors cannot be tested in the open air because it's a source or ultraviolet source. You cannot be put on just like that because it will interact with air and ozone will come out. We cannot do it in lab. So we had to make a vacuum chamber, thermo vacuum chamber. Within that thing, the optics has to be kept and it has to be focused. And once in a vacuum chamber, you cannot do manually any operation. We cannot focusing, we cannot do it there. So it has been done remotely. So we had to put in a moving mechanism X, Y, Z within the chamber. Then we found we need a collimator. A light source has to be there, a UV source has to be there. And a vacuum chamber, we had only about a 2 meter length. With the collimator and the optics put together, the length is not sufficient. The lab was only about 4-meter length. So we cut open the wall in the lab and made a longer collimator which goes beyond the lab to outside, and the temperature was the issue. So totally the image was, source was put inside, and it tested, remotely we tested. It has to be done every week. Once you do it, accuracy is not sufficient, take out the optics, go back, work. It took almost 2 years to complete the telescope, 2 telescopes, plus 1 for engineering model. Then IAA is doing the integration. They said they also need a collimator. The collimator is nothing but the same optics that we fly. Okay, so same, that was used as a collimator. So we had to make so many optics and supply it. Then the difficulty came, how will you take this optics to IAA or elsewhere? Even a small dust will affect the surface quality, and scatter will start. So finally it was decided the optics will be taken inside a vacuum chamber. We built a vacuum chamber. The whole vacuum chamber was put in a small vehicle and taken to IAA. It was kept there. The chamber was kept throughout the integration. Whenever you want, take it out. The vacuum was maintained. That's how the optics was made and did the job. Later I moved to ISAC as the ISAC director. Then my task became integrating and discussion with all other developing teams, TIFR and IAA very closely. I went to TIFR and saw the optics being made for the X-ray. X-ray telescope, as you know, it is one of the toughest thing to make. I closely saw how they are making. X-ray cannot be, it will transmit through anything except through the grazing angle. Optics has to be made. So the engineers at TIFR were working on that thing. One by one concentric rings were made in a week. Every week he could assemble only one. It took almost 6 months to 8 months to make the telescope. That too without dust, that will be concentric, and it has been made very tough job he has done. I will congratulate him and salute him for making this wonderful telescope for the X-ray, and the results show the excellent performance from that. So the other X-ray payloads at TIFR is a bigger one, and the matching payloads from ISAC and other places were also, other laboratories also joined with this effort. I will also mention the effort done by Professor Kembavi's team for post-launch activities. How to do this data, get the proposals from different people, analyze it, allot the time for the telescope to look at it, and also the data reception and formatting and storing in a data center in Bengaluru. All those efforts, IUCA's contributions were excellent. Without that, we could not have done a job of this magnitude. At the management side, all the centers and the participating agencies worked very well. As a chairman of the mission board, I had to deal with all the centers. Many of them were even seniors with me, and many of them were delaying the projects. I had to use sometimes some harsh words, but I can't use such harsh words to other centers, though they are all equally senior people. But with all this, everybody cooperated. It took almost 10 years for developing it. Very many problems came throughout the developments. Even toward the end, the last year, we found the detector, the imported detector had a major problem. We almost gave up the hope whether we can fly or not with that detector. We exported it back to the supplier. By the time the people have changed there, they said they are no more responsible for repairing it. With all sorts of difficulties. Project Director Kotesh Rao visited them and pleaded with them whether we can get the device back. And we had some contingency plans also planned as a URSC director. I had to plan for contingencies, whether we can get alternate detectors. We were about to order some of them, even in spite of it may delay by another year. But fortunately, the detector came in time with a minor repair, and it worked excellently for the last 10 years. I would congratulate our foreign collaborators for making this happen. So many people work together to make these achievements. And satellite side, engineering side, we had doors opening, closing for the telescopes. The IISU made a special gyroscope. And satellite side, a lot of technologies are to be made. All of them worked very well. Let me congratulate each of the members who contributed excellently for the success of this mission, saluting each one of them. Let me remember many veterans who contributed to the success of the project, starting from Professor U.R. Rao, Dr. Kasturi Rangan, and many more people worked with this project. Dr. George Joseph, for SAC, former SAC director, he was deeply involved in this project as the chairman of the science board. Let me remember all the contributions by all the great people. Let me thank the organizers of the conference for providing me this opportunity to participate in celebrating the success of AstroSat for more than 10 years in orbit. Thank you.
Thank you, Dr. Alex. Your support has been tremendous and your harsh words have not been harsh and have been much appreciated by the payload teams and the teams that were involved when you look at the achievements of AstroSat over the years. Now let me call upon Dr. Anadure, who is not here, but he has sent a video message, former director of ISAC, and also the first project director of Chandrayaan-1, the maiden mission to the moon. Dr. Anadure has been, again, very supportive in the last phase of AstroSat. Just before launch, there were numerous challenges that we faced, and with his support and focus, we were able to actually achieve it. In particular, also taking up the activities that Dr. Alex, etc., had supported with regard to the ground segment, setting up the ISSDC that was set up for Chandrayaan-1, transitioning to AstroSat, and which has now played an important role in actually bringing the community of scientists, not just from India, but globally. And that has been one of its unique elements of it. So with that, we will like to hear the video message from Dr. Anadure.
Please accept my heartiest congratulations and best wishes for the 10th anniversary of AstroSat in orbit. It's really, really heartwarming to know AstroSat is doing well much beyond its design life and mission life. Heartiest congratulations to the entire team of AstroSat, instrument scientists, engineers, and the mission planners, making this to happen. And definitely it is a time to think for AstroSat 2. I think probably ISRO will be thinking about that. Very unfortunately, I could not be part of today's celebration because of my pre-committed assignments and travels. Notwithstanding that, definitely I heard also looking back nearly 4 or 5 years of association of the AstroSat as the program director since 2010, and subsequently during its final integrations of the instruments and making the launch to happen through PSLV in 2015. And it's really, it's heartwarming bringing the scientists of astrophysics across the Indian laboratories, even from the foreign labs, and working with our own engineers in ISAC, ISRO Satellite Centre, and making the very, very special efforts, either to make corrections of the instruments, or even to make a serene, clean room for the AstroSat, first of its kind, within ISRO centers, and making all the instruments required cleanliness. And towards that, I know very well, K. Sharma as a project director was running poles pillars, and the entire team also, the young team was working. Of course, it was a long, journey from the conception to the realizing the instruments and integrating them in the spacecraft, and making the PSLV ready for this, and putting the mission into action. And now it's heartwarming to know a good number of findings have come. This is one of the first multi-wavelength satellite for astronomy point of view, and definitely it has paved the way how the scientists, engineers can work together for a common cause of the world-class AstroSat satellite and its working is concerned. And I know it is AstroSat and Chandrayaan, these two marriage together only paved the way for redefining Aditya alone. Very much remember that. And experience gained from Chandrayaan 1 and the mission planning, combined with AstroSat realizing, bringing the astrophysicists and spacecraft engineers together. This definitely gave the boost for Aditya alone. And that way, definitely it's a paved way for what India can do and ISRO can do. And once again, my best wishes. While we are celebrating, I think you will think about AstroSat 2 also and beyond. And the young and energetic engineers, when I go across India, I could see, and many of them are asking and expecting the follow-up of AstroSat. Hope that will also happen there. Once again, my best wishes, and my heart is with you. Thank you, thank you, thank you very much.
Thank you, Dr. Nandura. We would have been happy if he was here today, but we understand his preoccupation. But thank you for those messages. Yeah. Now let me call upon Professor G. Srinivasan, former senior professor at Raman Research Institute, and on whom Dr. Kasturirangan had actually leaned heavily to really bring the community of Indian astronomers together. And there were many years of work in the pre-approval phase that was required to create this cohesive concept of a mission that extends from ultraviolet to X-rays. So he has been a key person both at the early phase of it, subsequently as a member of the AstroSat Progress Monitoring Committee chaired by Professor George Joseph. He has been an important player in addressing many concerns that have arisen, both technical as well as sometimes personal. These are very important to really bring the community together. As the president of the Astronomical Society of India, he was also very key in actually enabling the similar sort of a cohesive element coming together for the Aditya L1 mission. So with that, let me invite Professor G. Srinivasan to say a few words in this occasion.
One day in October 1994, I remember very vividly, it was the day after the first successful launch of PSLV. As I was entering the Raman Institute, Professor Dhawan was coming out. And he had just returned from Sriharikota after watching the launch. Standing near the gate of the Raman Institute, he told me how supremely confident the engineers were that the launch would be successful. And he told me, I remember these words, that this supreme confidence was not based on any cockiness, but on the thousands and thousands of simulations they had done. And then he asked me the following in his very characteristic manner. So many thousand kilograms went up, so many thousand kilograms are up there. Why isn't there an astronomy experiment on board? 3 days later, I went and met Dr. Kasturirangan, chairman of ISRO, and discussed the feasibility of an astronomical satellite. Dr. Kasturirangan, without any hesitation, said to me, you come to me with a meaningful and viable project, and I shall consider it. Then for almost a year and a half, I convened a series of meetings in which astronomers from all over India were invited. Professor Kumar Chitre of Tata Institute and myself, we alternated and chaired these meetings. These meetings were held in the basement of ISRO headquarters. And after roughly a year and many, many meetings, a consensus was reached. The consensus was that AstroSat will be a multi-wavelength satellite. Right from the beginning, a few of us, Dr. Sri Kumar in particular, were convinced that this opportunity must be used to initiate research and development in new areas. And this insistence led to the development of the soft X-ray telescope, pioneered by Professor K.P. Singh, the CZT detector, led by Professor A.R. Rao. These were extremely challenging efforts, as Dr. Alex mentioned to you, and it required a tremendous amount of courage to undertake these developments. Some of us, in particular Dr. Sri Kumar, were convinced that at least one instrument on AstroSat must be better than anyone else has flown before that. At least one instrument must be better, and that was to be UVIT. One knew right from the beginning that it's going to be a very difficult telescope to build. The first task was who will build the mirror, make the mirror. And it was very clear that the only hope was if LEOS agreed to make the mirror, and Dr. Alex was very reluctant to undertake this job. And I remember almost for 1 year, I put tremendous pressure on Dr. Kasturarangan to twist Dr. Alex's arms to agree to make this mirror. And of course, they made 3 fantastic mirrors, and they passed this with flying colors. But that was not enough. You needed somebody who understood the whole of the telescope, right from the detector to the engineering aspects. And everyone heaved a great sigh of relief when Professor Tandon agreed to lead this development. Once the mission was approved by the government, it took about a year or so, more than that, the PIs of various instruments had to start interacting with engineers in ISRO. And this was a very, very turbulent period because astronomers exhibited the typical attitude. We know what to do. We don't need to talk to these engineers. Slowly but steadily, the PIs and their associates in various collaborating institutions discovered the tremendous value of interacting with ISRO engineers, and indeed it was essential that they did so. In my personal opinion, that symbiosis between the scientists and the engineers was a key to the success of the mission. And sadly, such symbiosis is rather rare in the Indian scientific culture. Even before the mission was formally approved by the chairman of ISRO, set up a monitoring committee with Dr. George Joseph chairing it. I and several people present here were a member of this monitoring committee. Now, Dr. George Joseph was a man of great experience, but he was a very, very tough taskmaster. The monitoring was not liked by most of the PIs and their associates. They were not used to this kind of rigorous monitoring. And there was a great deal of resentment to this monitoring committee poking their nose into every little bit. But in my humble opinion, I am absolutely convinced that the success of the AstroSat, which we are now celebrating, is largely due to the most rigorous and uncompromising monitoring by the George Joseph Committee. And I say this for a very particular reason. I noticed that the subsequent scientific missions that ISRO approved, some have been flown, some are in the pipeline, do not have a corresponding monitoring committee with experts from outside ISRO also. And I urge the PIs of these newer missions to adopt the template of the AstroSat Monitoring Committee. Before I move on and look ahead, rather than reminisce about the past, we are having this 3-day conference, and Professor Dipankar Bhattacharya mentioned the enormous number of papers that are going to be presented. But please remember, this is only possible because AstroSat data is being used. This is not common culture in India. People own expensive instruments, but they tend to be extremely possessive about it. Long before AstroSat mission was approved and people started building AstroSat, Professor Sri Kumar, Dr. Sita, and many others started conducting AstroSat workshops where they invited students from universities and trained them on how to use data from space. So that from the moment that the data became available, people started using it. So I encourage the scientists who are planning future missions to pay great importance to this outreach program, and that must not be something you do afterwards, that you must do from the day you begin to think about the mission itself. That's enough reminiscing. I would like to, in the next couple of minutes, look ahead, although that was not the mandate given to me. I often hear a talk of follow-up mission to AstroSat, another grand observatory. In my humble opinion, I am not sure that such a thing is either feasible or even sensible. In this context, I would like to recommend to you an article written in Physics Today in 1971 by the great physicist Freeman Dyson. It was called The Future of Physics. This article has been reproduced every 10 years in leading scientific journals. I encourage Freeman Dyson, 1971, Physics Today. It was called The Future of Physics, in which he talked about the spectacular success of the Cavendish laboratory after Sir Lawrence Bragg took over from Lord Rutherford. Here are some morals from that article. Moral number 1, never try to relive moments of past glory. Never try to relive moments of past glory. 2, never jump on a bandwagon simply because it is fashionable. 3, avoid crowded frontiers. Look for newer, if not new frontiers. The great physicist Sommerfeld, whose students created quantum physics, said this: in research, you must always work on problems where you have an undue advantage. This brings me to a few final remarks. It is now the policy of the Government of India. The space sciences will not be confined just to ISRO, but will be a national adventure. Nowhere else in the world, any space agency offers free satellites and free launches like ISRO still does. In the coming decade, ISRO's main interest will be lunar and planetary exploration. So I wish to say this to my young friends who are planning for future missions. By reorienting your interests, you can have an undue advantage of exploring brand new frontier, namely the frontier of planetary science, which is the thrust area of ISRO. Please remember, there is no virtue to being an also-ran in a crowded frontier. What counts is the impact one makes and not the number of papers you may publish in Nature or Science. It is the impact that one makes. After the dust settles down, that's what really matters.
So, excuse me, sir.
So jump on this bandwagon, ISRO's bandwagon, which is exploration of the moon and the planets, and you will have an incredible advantage of having facilities like URSC, LEOS, SAC, and the Space Science Instrumentation.
1 minute silence for the Martyrs' Day. Thank you. You may resume your seats. Sir, please continue.
If young astronomers reoriented their interests towards planetary science, they will have the incredible advantage having facilities that are available at URSC, LEOS, SAC in Ahmedabad, and the Space Science Instrumentation Facility here. Just reflect, how many scientists in the world have such a luxury? Finally, I would like to recall that long time ago, when the great astronomer Russell retired from Princeton University, the chair was offered to Professor Chandrasekhar at the University of Chicago. And he accepted the chair. But the president of the University of Chicago called Chandrasekhar and said the following: "It is better to occupy a chair that becomes fashionable to succeed rather than to occupy an honorable chair." So I say to my young friends here, don't jump onto wagons that are fashionable. Jump onto a wagon that becomes fashionable to jump on in the future. Do not try to emulate people like Professor Agarwal, K.P. Singh, Shyam Tandon, A.R. Rao, and others. Rather, do what you want to do, but be brave and courageous as they were, because there was no guarantee when they went into this, and it took a very long time that it was going to be a success, let alone work for 10 years. So it is the courage and the commitment, as Professor Agarwal mentioned in the end, that you have to emulate and not repeat what they did long time ago. As Francis Bacon said several centuries ago, they are ill discoverers who think there is no land when they can see nothing but sea. Good luck to all of you. Thank you.
Thank you, Professor Srinivasan, for taking us back on that memory lane, the early days of the planning, etc. I also want to point out the fact that when Professor G. Srinivasan was the chair of the time allocation committee of the large world-class radio telescope, GMRT, he set in place a mechanism to actually, for people to propose for observations from an observatory. We largely adopted that for AstroSat, and much of today's large community of users of AstroSat is directly linked to the establishment of the AstroSat payload proposal submission system that is in place today. Now let me call upon Dr. George Joseph, who could not be here, and former director of SAC, and former chair of the ADCOS, Advisory Committee for Space. And as Professor G. Srinivasan just now mentioned, he was a key player as chair of the APEX AstroSat Payload Monitoring Committee, which would meet regularly over years to continue to really ask difficult questions, push us through, and has played an important role in actually enabling AstroSat to be such a successful mission. So we thank Professor George Joseph and the complete team of the Payload Monitoring Committee that has actually enabled this mission to be very, very successful. So thank you, Professor George Joseph. I now like to call upon our first project director, Dr. Koteshwar Rao. As we've already heard about the key role he played and how Dr. Goyal had the trust in him to take us forward. In the years he has actually, initially setting up the whole program, he had the challenge of actually dealing with scientific community outside ISRO, which is not an easy task at all, and I'm sure he has many things to say. But in my personal view, I think this interaction that he had with the larger scientific community has made an important impact on him in his subsequent years, and I think we'd like to hear from him. Dr. Koteshwar, please tell us about your experiences.
Good morning to all of you. The story of AstroSat, spanning over almost 3 decades, and which has seen 4 chairmen of ISRO, 5 directors of Satellite Centre, 2 PIs, and 2 project directors, is like a big story, like Ramayana. So I had many roles during these 3 decades, To start with, in the first decade, as a member of the study team, and in the second decade, first half, as the project director of AstroSat, and in the third decade, overseeing the mission operations as a committee chairman of the Mission Operations Review Committee. So with such a vast span of 3 decades, and recalling the reminiscences and telling to this audience in 5 minutes is like telling Ramayana in 3 words. But still, somebody did it. In my mother tongue Telugu, he told, Katte, Kotte, Teche. Translated into English, constructed, killed and brought. Meaning, Rama has constructed the bridge, killed Ravana and brought Sita. This is the Ramayana. See, in the same analogy, if I have to tell about AstroSat, I have to say conceived, launched and utilized. This is the brief. And to start with, as Dr. Goyal has already mentioned, one day he called me to his office and broke the news that I will be appointed as project director. I asked him, do I have a choice? He smiled and told, you have a choice, but the chairman wants you as project director. So message is very clear. So on 3rd April 2003, the order was released identifying a project director, 1 PI and 2 program managers and 3 project managers. After 2 weeks, I left LEOS and joined Satellite Centre and went to Dr. Goyal and asked him to whom I have to report. At that time, 2 program offices were there in Satellite Centre, called IRS Program Office and GeoSat Program Office. I was expecting him to tell me to report to one of the program directors, but he told, you report to me directly. I asked, why, sir? I am thinking of having another vertical of Science Missions Program Office. Till a program director is identified, you report to me. That went on for some time, and before he could do it, he went into some other engagement at some other ministry. But that the dream of his came through much, much later when the present director, Dr. Sankaran, has made a program office for Space and Space Exploration Program, which is headed by none other than Jashwinder, who was one of the DPDs of AstroSat. I am very glad that he took up that position. And any project like an automobile, in the initial phase, it needs a lot of torque, but with low speed. I think I took up the job of providing that momentum. And after I left project and went to LEOS as director, Mr. Surnarayan Sharma, who is very capable of handling projects, who has experience of mission operations, took over and changed the gears and provided the required speed to launch it in the year 2015. And as soon as I was appointed as project director, Dr. Kasturi Rangan called all the veteran scientists for a meeting and introduced me in his usual manner, using all adjectives about me, that he has appointed me as project director. I think Professor Srinivasan was there, and he commented, it is very nice to see a man with black hair as project directors. All others were gray-haired. I did not understand the comment at that time, but when it took a decade to realize and launch it, by the time I was retired, I retired in 2014, and 2015 it was launched. Then I recalled that sentence and remembered what meaning it had. So the message to youngsters here is the projects of such magnitude take a long time, particularly when the challenges are heavy. Like that, Dr. Alex has mentioned, as far as UV telescope is concerned, we have taken a challenge. That time, the best telescope, UV telescope in the sky was Galaxy with 5 arc seconds resolution. And we took a stand, we should better it. The goal was 2 arc seconds. And thanks to Professor Tandem, today we have achieved 1.5 arc seconds. That is a real achievement. I don't take much time, but some of the hurdles, many hurdles will be there in realizing such project. The moment I joined ISAC, I had to find a sitting place. That time 5 rooms were constructed in Satellite Centre, popularly called as PD's Enclave, and I was offered one room. I went to that room and there were no neighbors, and the entire area was full of dust. So I have to get it cleaned. I have to get some telephone connection, and I have to get a PC and work with that. At that time, there was a shortage of stenos and helpers. I was not provided with any steno or helper for a long time. So I had to type the entire project report with my own hands and submit it for approval. But that hard task has got an advantage, which I will tell you at a later stage. And before I was appointed as the project director, there was a call from Scientific Secretary's office that time. And he called me and told, Dr. Rangan asked me to interact with you. And that room was full of smoke because he smokes a pipe. And I could not bear the smell. And I told, sir, can we talk outside? Then we went outside. And he interacted with me and he asked me, why you want to take up the project director post of AstroSat? I hesitated for a moment and told, sir, that I did not want, but it looks chairman wants me as project director. And at that time he appeared to be unhappy with me, but at a later stage, I will connect that incident of typing my whole report. It was a holiday. I was in my house and he called me. Koteshwar, where are you? I told I am in house. Do you have a computer in front of you and a soft copy of your report? No, sir, I don't have a laptop or a desktop, which offices not given those days. Laptop and mobile were a luxury. Only very high officials were given. Then he asked me, no, I am seeing a flaw in your report. The contingency money you have not provided. Then I thought for a while, few seconds I took, and then I told him, sir, in so-and-so page, if you see, contingency amount so-and-so is provided. He got astonished and he told, how do you remember? I told, sir, the entire report I have typed with my hands and revised many times, so I could tell. Then his opinion about me changed a bit. So like this, many events are there. And I am very glad that Professor Srinivasan has mentioned about the collaboration between scientists and engineers. That was a huge task. They come from different cultures. The culture of the scientific community and the culture of engineers at Satellite Centre, not totally different, but a bit of differences were there. In the first meeting after Madhavan Nair took a chairman, he took a review of AstroSat and asked me, Koteshwar, what is your achievement so far? I smiled and told, sir, my biggest achievement is to bring the scientists and engineers to the same table. I think this paved a lot of groundwork for the success of AstroSat. And not only the collaboration with scientific institutes across the India, we also had collaboration with University of Calgary through Canadian Space Agency and the University of Leicester. I am glad to see some of my colleagues from Leicester University, if I remember them vaguely. It was a very good collaboration in the sense we opted for no money transfer. No money transfer. We only give a part of the observation time of the AstroSat. That was a very unique collaboration, which stood very well till today. And AstroSat gives me immense pleasure as I stand before you today after 10 years of launch. The very fact of the compact schedule for these 3 days, particularly on the science outcome, proves the importance and grand success of AstroSat, which is well recognized by the astronomical community, and the astronautical community is yet to do that. At this juncture, I assure you that AstroSat is going to be there for many more years to come. I am sure that many of you, and hopefully I, would be celebrating the Silver Jubilee in the year of 2040 along with an Indian on moon. Thank you very much. Jai Hind.
Thank you, Koteshwara, for taking us through that whole process of building of the AstroSat. I also want to emphasize the fact that Dr. Koteshwara continues to be deeply involved in all the science missions that have been since then come up and the ones in future as well. So we look forward to continuing support and guidance from him. Let me now request, we'll have a short video from our second project director, Mr. Suryanarayan Sharma, who couldn't be here today. He has sent us a message. Now, he had taken over the overall responsibility of AstroSat from Dr. Koteshwara, and he had the tough task of actually closing the project, pre-launch. Lots of issues are there. And he managed to do that with his very patient, quiet approach of convincing people. And he also had the challenging task of being simultaneously also responsible for the Aditya L1 mission at that last phase of AstroSat. So with great capabilities that he demonstrated, an ability to pull everyone together, get the systems ready for the 2015 launch. So we will now hear the message from Sharmaji.
Dear respected seniors, distinguished scientists, my colleagues and friends, greetings on this special occasion. I want to extend my heartfelt thanks and deepest appreciation to everyone who made this journey possible. Actually, this achievement belongs to many hands and many minds. Firstly, a special note of gratitude to the seniors in ISRO and other institutions who conceived, defined this flagship mission to strengthen the astronomy and space sciences and the capabilities in India. Their vision, strategic guidance shaped this AstroSat mission. This is not only a multi-wavelength space observatory, but it is a multi-institutional, national and international collaborative strength. And their vision really left to this triumph. I also want to acknowledge and place on record my special appreciation to the payload instrument scientists who conceived, designed, built, and calibrated them to the world-class instruments. I saw them work in their labs, and while they're integrating it with satellite, they are very diligent and passionate about it. Their deep scientific insight, engineering ingenuity, and their meticulous attention to the details really led to this exceptional performance and then such an impactful science outcome. I would also like to specially appreciate our engineering teams at ISRO who designed and built the spacecraft mainframe and bus systems which hosted these sophisticated instruments. And then my appreciation to them for who integrated and tested it also. they all provided such a robust platform which outlived the design life. My sincere acknowledgement also due to the launcher team who gave such a precise and a wonderful launch. My then appreciation to my colleagues at mission planning and in-orbit operations team who diligently and meticulously planned and executed AstroSat operations. Their sound strategies, careful resource management, and timely decisions while whatever they encountered while their operations going on. It all led to the good satellite health performance while maximizing the scientific observations very well. My appreciation is also due to the teams who built ground support systems like hardware and software systems. I sincerely acknowledge finally the international collaborators who are involved in this mission and their different partners, and then data centers, and then global scientific user community. My thanks to them, and then I appreciate all their involvement in this mission. As project director, I consider it is my privilege to have been associated with this mission and with such an very wonderful professionals in the team. I wish you all continued success and many years of meaningful scientific discoveries. Thank you and all the best.
Thank you, Sharmaji, for those wonderful words and for providing AstroSat as a successful mission in the post-launch phase of it. I think we've come to a conclusion of the first part of this discussion, and the message that is loud and clear is that everyone has actually emphasized is the collective responsibility, the collective mode in which we work together in spite of differences. I mean, we are, as you know, someone Koteshwara pointed out, scientists and engineers have worked differently, but we managed to do that, and I think that's the message for the next generation of people who are going to be involved in it. So let me thank everyone who spoke today, and the message has gone to the upcoming youngsters.